Now, ladies and gentlemen, when we talk of correlation, core comes from the word common. So correlation basically is a measure of the bond, is a measure of how strongly are two variables related. So you're saying that correlation measures the bond. It measures the bond between two variables. It measures the bond between two variables. It measures the bond between two variables. The question will be, how strongly are these two variables related? So if you have got some variables that are so strongly, perfectly correlated, ladies and gentlemen, you will talk over, in this case here, types of correlation. Types of correlation. We have here, number one, perfect, positive correlation. So these normally exist whenever we have our R being exactly equal to what here, somebody? Positive 100%. So the relationship is perfect. And this can only happen, ladies and gentlemen, when you have your line of best fit going through all the points. Positive relationship. We have here as X increases, what happens to Y? Y is also increasing in a perfect way, a perfect fitting way, a perfect fitting way. And then, ladies and gentlemen, we have the same approach, but now this time round, when we talk over number two, perfect, but now this time round, negative correlation. Perfect, negative correlation. So you're writing there, perfect, but this time round, negative correlation. Negative correlation. So perfect again, we'll have our line of best fit going through all the points, but this time round, ladies and gentlemen, the gradient is what here is an inverse one. The gradient is negative, As X is increasing, Y is decreasing. Y is decreasing. So perfect negative correlation, that's how it behaves. From there, ladies and gentlemen, we have a situation where we have the two variables now not related at all. So number three, where there is no correlation, no or zero correlation. So the two variables will behave like this. So you'll have, in this case here, your points are having your scatter diagram. Even if you have to do a line of best fit, you'll be able to see that there is no clear pattern that is being discerned here. There is no clear pattern that is coming out here. So there is no matching, so no perfection. And at the end of the day, because these points are just scattered anyhowly, then the correlation, the bond between the two is basically what here is basically zero. The bond between the two is basically zero. It's basically zero. Now, how do we measure correlation? How do we measure correlation? Ladies and gentlemen, to measure correlation, there are basically two models, which we must be remembering. For our exam purposes, to measure correlation, we have got two models. Number one, we have what we call the Pearson's model, the Pearson's model. And then number two, we have the Spearman's rank model. The Spearman's rank what here? Model. The Spearman's rank model. The Spearman's rank model. The Spearman's rank model. Of course, the examiner, you'll always want you to differentiate between these two models. So how do we get to differentiate between these two models? The Pearson's model is normally used in situations where the variables whose bond you are after evaluating are quantitative in nature. So quantitative variables. Quantitative what here? When the variables are quantitative in nature, quantitative variables are those variables that are measurable. variables that you can count, variables that you can attach numbers. You can, for example, if I wanted to know how heavy I'm weighing today, what will I do? I'll simply get a weighing scale and get to measure my weight. I can also measure my height. I can count number of students in a particular classroom. So ladies and gentlemen, all those variables that are either countable or measurable, we call them quantitative variables. And if you want to see how they are associating, what is the bond between the two, then you will use what we call the Karl Pearson's model. And then, ladies and gentlemen, we have the Spearman's rank model. This is a very good model, which is normally used to capture qualitative, used to capture qualitative what here? Variables, used to capture qualitative variables. Qualitative variables are those variables that you cannot count, those variables that you can't measure. We call them qualitative variables. Variables that you can't count, variables that you can't measure, we call them what? Qualitative variables. Ladies and gentlemen, are those variables that you can't count, those variables that you can't measure. For example, which one? A very good example of a variable that you can't measure, you can't count, is female beauty. It's female beauty. There is no way you can. Of course, you say that this lady is beautiful, but how do you attach a numerical value to that beauty really? It's not possible. It's not possible. It's not possible. Now, ladies and gentlemen, that now takes me straight away to this model. This lesson basically will be for the two models. So I would want us to take this opportunity to remind ourselves the Karl Pearson's formula. The Karl Pearson's formula. The Karl Pearson's formula. The Karl Pearson's formula. What do we have here? The Karl Pearson's formula. What do we have? I would want to see whether there is anybody who will be able to remember to write it down. Kindly write it down. So, ladies and gentlemen, when we talk of the Karl Pearson's model, the Karl Pearson's model, the Karl Pearson's model, the Karl Pearson's model, always remember the formula of getting the gradient. To get the gradient as per regression analysis, our gradient is normally obtained by us taking B gradient, by us taking n summations of xy minus summation of x summation of y, all over n summation of x squared bracket sum of x done what here? Squared. So whenever they want me to give them the correlation coefficient using Karl Pearson's model, first of all, I'll be forced to remember this formula B. And then from there, ladies and gentlemen, now I should be able to get my R. R is quite similar to this B. To get this R, ladies and gentlemen, the numerators are the same. So n summation of xy minus sum of x, sum of y, all over. The denominator are pretty similar, same. So I'll talk of n summations of x squared minus bracket sum of x squared like that. But because of the association between the two, x and y, I must come and introduce a section where I capture the y using the same variable, ladies and gentlemen, the same variable here, same format, I mean, but this time around using y. I'll talk of n summation of y squared, just like this, n summation of x squared. But now n summation of y squared minus open bracket summation of y squared. So if you wish, you can have one big square root or have two of them. Have two square roots like that. So that is my formula. That is my formula for getting my correlation coefficient R, of which I would want us to look at an example straight away. An example straight away. So if you're given here xy, then you have here 5, 8, and maybe 9 versus 10, like that. So only 2 points like that to simplify our work. And then you have a situation where the examiner wants you to get R. The examiner wants you to get R. The examiner wants you to get R. So I want to give you exactly 1 minute. You try. So ladies and gentlemen, I need some 2 extra columns here, 3 actually. I need a column for xy. I need a column for x squared. and I need a column for y squared. So xy, 5 and 9, this gives me 45. 8 and 10, this gives me 80. And then we have x squared. So x squared, 5 squared gives us 25. 8 squared gives us what here? 64. And then we have y squared. Y squared, so 9 squared gives us 81. 10 squared gives us what here? 100. So ladies and gentlemen, having gotten that, could you kindly come and give me these summations? So summation of x, we have 5 and 9. This will give us 13. We have summation of y, 9 and 10. This will give me 19. 19. Summation of x, y. When you add the 2, this will give me 125. And then we have summation of x squared. When you add here, this will end up giving us 9. This will be 89. And then we have summation of y squared being 181 like that. 181. So if that is the case, I'll straight away come and plug in the figures. We plug in the figures. So when we plug in the figures, what shall we get at the end of the day? So my area will be equal to n. Number of points are how many? There are 2. Number of points here are 2. So I'll talk of 2 times summation of xy, which is 125 minus, I'm following this formula. I'm following this formula. Summation of x is 13 times summation of y, which is 19. All over, we have here root, the square root of n. Again, n is 2. We have summation of x squared. This x squared, summation is 89, minus, into brackets here, summation of x, which is 13 squared. So square root again. So what do we have here, somebody? N, summation of y squared. So n is 2. Summation of y squared, summation of y with a square, this one here, is 181. 181 minus summation of y alone here, this summation of y, which happens to be here 19. 19 what here? 19 squared. So 19 squared. So I would want to see whether there is anybody who will be able to move slowly, move very slowly to give us the numerator. R will be equal to what? Somebody give us the numerator. Somebody give us the numerator. Somebody help me here. Give me the numerator. Somebody give me the numerator. Already they have the answer. The numerator, I'm being given a numerator of 3. A numerator of 3. How about what we have under the first square root? What do we have here under the first square root? Under the first square root, somebody 2 times 89 minus 13 squared. Somebody help me out here. What do we have, ladies and gentlemen, here? People are telling me it's 3. 3. So root of 3. And then we have here root of what here? What is 2 times 181 minus 19 squared? So just using your calculator, what do we have over there? Using your calculator, it will be 2 times 89 minus 169, which will be square root of 9. So square root of 9, that gives me what figure, somebody there? 3. That gives me 3. Come here again, give me the second square root here. So the second square root, I'm being told here, it's 2 times 181, 2 times 181 minus 19 squared. So minus 19, which gives me, ladies and gentlemen, what figure here? Which gives me 1. Which gives me 1. Thank you, and thank you very much. So then at the end of the day, 3 divided by 3 will give me 1, which is 100%, which means a perfect positive correlation. A perfect positive correlation. a perfect positive correlation. So this one, I'm so sure you guys do not have any issue with this. So our R is 1, which means a perfect positive correlation. Positive correlation. Now, how about this one now here? The ranks model. Mentioned there the ranks model, which was given by Spearman. The Spearman, just like that. Where these people will come and they give you, for example, students. So the students, they'll give you, for example, A, B, C. We have here position in the form of mathematics. Then we have position in English. So position basically means rank. So mathematics, this student was number 1, number 2, number 3. In terms of English, this student still was number 1, B became number 2, C became number 3, like that. So we are required, ladies and gentlemen, we are required here to determine the coefficient of correlation, using ranks model. Determine R using ranks model. Determine R using ranks model or Spearman's model. Ranks model or Spearman's model. Ranks model or Spearman's model. So if I'm given this kind of a question and they want me to use ranks model, what I'll do, I'll come and write the model for them. I'll tell them that R should be equal to what here, somebody? R should be equal to 1 minus 6 summation of D squared all over N cubed minus N. It's a formula which we have to cram. 1 minus 6 summation of D squared all over N cubed minus N. Where D stands for differences between ranks. Differences between ranks. Differences between who? Ranks. And I would want us to come and create a column here and mention here D. Remember, position is the same as rank. Position is the same as rank. So come and create a column here where you capture your D. And I would want us to square it automatically. So I would want to, whatever difference we get, we square. Whatever difference we get, we square. Whatever difference we get, we square. So our D squared, ladies and gentlemen, like now the first one, we are taking rank of A in maths minus rank of A in English. Whatever we get, we square. So 1 minus 1 is 0. 0 squared, of course, in this case here will give us what here? 0. 0. Come here, 3 minus 2 is 1. 1 squared gives us what here? Somebody 1. 2 minus 3. 2 minus 3 is minus 1. When you square minus 1, what are we able to see? Minus 1 squared still gives me 1. But then they want us to sum, summation of this D squared. So could you kindly sum for us and give us this figure? Give us the summation of D squared. The summation of D squared is quite easy. The summation of D squared, 2. Thank you very much, Fidelis. Thank you, John Zhao. So we have 2 there. From there, I'll be interested in N. N will be representing the number of students in this case. Ladies and gentlemen, in our case here, N will be representing number of students. N will be representing number of students. So this N being number of students, how many do we have? 3. And then, of course, as per the formula, they want me to give them N cubed minus N. As per the formula, they want me to give them N cubed minus who? Minus N. So my N here is 3. So 3 cubed minus N, which, please give me the answer. 3 cubed minus 3 will give us what figures? 3 cubed minus 3 will give us what figure? Somebody's giving me a figure of 24. Thank you very much. 24, 24, 24, 24. Someone is giving me a figure of 24. Now, once I have that, then I should be able to get that R through fixing the parameters that we have. Now we should be able to have our R, ladies and gentlemen, there by fixing the parameters that we have. So then at the end of the day, what do we have here? We have our R being equal to 1 minus 6. Don't ask me where this 6 is coming from. It's a formula. It's a formula. It's a formula which you have to cram like that. So minus 6 times summation of d squared. Summation of d squared is 2. Don't square again because you squared individually. So summation of d squared is 2. All over, ladies and gentlemen, this n cubed minus n, which you guys gave me a figure of 24. Which you guys gave me a figure of 24. Which you guys gave me a figure of 24. Which you gave me a figure of 24. Which you gave me a figure of 24. Thank you very much. Therefore, this will be 1 minus 6 times 2 gives me 12. All over 24. 12 over 24 is 0.5. 1 minus 0.5, that gives me 0. What here, somebody? 0.5, and that is the answer, 0.5. So the measure of association, the bond between these two is average. Is average. Not so low, not so high. The bond between the two is what here? Is average. The bond between the two is average. There is a student who has written his or her name in Arabic. Very good, but I can't read that one now. I can't read that one. But I can see Zamzam has 0.5, Kate, Dorcas, Wycliffe. I remember Wycliffe, yes. Wycliffe with a WI. So now in my next question, I'll be showing you what we shall be doing whenever we get what we call tied ranks, where students, in this case, here tie up in some position, where they tie up in some position. So please keep glued here. You shall be able to see what we normally do whenever we encounter students, for example, who fall at the same position,